2960 in the real world, that switch support the PoE, but this switch in the packet tracer doesn't support it. Because of that, as you saw, I have connected the adapter to the AC adapter interface. Now, let me to use another switch. This is the 3560 switch of the packet tracer. This is a PSE. This switch can support sending the power because the hardware of this switch has this capability to the, for example, one power device such as the IP phone. Look at here. When you are installing again one IP phone, this is the IP phone, and if you are connecting this device to the for example, PSE, without the need to connecting the IP phone with the power adapter to the AC power, the IP phone now is for example, turning on. Look at here. As you can see, now the IP phone is working. Why? Because the PSE, this switch now can supply the power of this device. Okay, the configuration is beyond the scope of CCNA, but only for informing. Let me to show you here in this device, in the switch, you can use the show, for example, in show power in line command, show power, and then in line, it can give you enough information about the power. Here you can see on the port facet and 01. Now we are offering power, 10 watt power to the IP phone 7960. And this means that this switch is the PSE switch with the capability of the PoE, but the 2960 in the packet tracer doesn't support it. Because of that, we don't have the command show power in line. Why? Because this is not a PSE. And also in this picture, you can see the power sourcing equipment PSE connected to the IP camera, to the IP phone, and also some other devices. Also in the switch that support the power over Ethernet, here you can see one statement about the PoE, for example, PoE or PoE plus supported. And after that, here you can see a yellow line. Okay, this yellow line under the ports means these ports are the PoE ports, and you can use these ports for supporting the for example, PoE, for giving the PoE to the other device. Also here you will see the PoE label. This means that this device is a PoE capable device. Because of that, this is related to the hardware of the switch in most cases, and if the switch doesn't support the PSE, okay, or the power over Ethernet, you need to replace the switch with newer switch in your design. Also, maybe in some cases we are using the power injector, but it's better today is that we consider the requirement of the powers when we are designing or choosing the switch for the, for example, network. About the PoE, we have another consideration. This is so important. You know that some device such as the IP phone, such as the access point, needs the power over Ethernet, okay? But some other device such as the network interface card of one PC doesn't need the power, because the power of the network interface card can be supplied with the power of the PC, okay? Because of that, if you apply the PoE to the to the network interface card of a PC, maybe the network interface card is corrupting, and maybe this is a, for example, consideration for the PoE appliement. You know that first we should understand that the other side needs the power. After that, we can apply the power. This is so important. I'm going to talk about this operation. Look at here. When you are connecting one device to one port of the PoE capable switch or the PSE, okay, first we should experience a negotiation between these two devices. After the negotiation, the switch can understand that it should apply the power to this device or not. Okay, don't forget, if you apply the power the device to the device that doesn't need the power, it can damage the device, and it is so important. This is the current more than the need of the, for example, one device. Because of that, first we have a negotiation between these two devices. If the negotiations result is that this is a PD, this is a powered device, you can apply the power to that device. The question is that how the switch can negotiate with the other side. Let me to emphasize that this is related to the, for example, the level 1 signaling. But also with the auto negotiation features of the Ethernet interfaces, we can talk about the PoE capability with the other device. But you know that first the other side interface should be enabled. After that we can talk about that. For example, about the PoE. For example, in the IP phone, by default this interface is shut down, and if you send negotiation message to the other side, okay, you don't have any, you will not have any response. The solution is that we can apply a small signal to the other side. If after that we can negotiate the parameters. Also, let me to emphasize that we have some electrical methods for understanding the other device is the PoE device or is the PD or not. For example, you can apply a little voltage to the 2 pin of the device in the switch, and after that you can calculate the resistance of that device. If the resistance is a specific amount of has a specific amount of value, this means that is the powered device, and if not, that is not a powered device. Or maybe in some cases we have another solutions. For example, in more powered device, when the device is off, okay, the pin in and pin out are connected to each other. This means that the device is residing in the short circuit status. Because of that, if you send a little signal to the other side, you will receive the other signal, and this means that this is a powered device. Also, we have another for example, options for detecting the next device is the powered device or is not a powered device. This is not important for us. This is the electrical communication, but we should know that by default switch doesn't apply, okay, power to the other side. First, the switch should negotiate with one method, okay, the method is not important, with the other side. If the switch determines that the other side is the power device, it can apply the power. Because of that, for example, this switch now is applying the power to the IP phone, to the AP, but not to the PC, and it is so important. Look at here, in this scenario, you know that now the switch is applying the power to the, for example, 7960 switch, or IP phone, okay, but if you connect the PC, the switch after negotiation understand that the PC0 doesn't need the power. Because of that, it shouldn't apply the power, and it shouldn't apply. Look at here in the show power inline. Here in the show power inline command, you can see that the port 2, okay, now doesn't use any power, but the port 1 now is using for example the 10 watt power, okay. Because of that, now we know that the PSE device understand the other side's requirement. If the requirement of the other side is receiving the power, the PSE should give the power. If the other side doesn't need the power, the PSE should not send power or more, for example, extra power to the other side. Also, after the for example, after enabling the power to the other side, we are using the CDP or LLDP, as I mentioned before, for negotiating the needs, the new needs with the other side, okay. For example, here now the CDP is working, and the power requirement of this for example IP phone is sending to the PSE. Let me to show you in the capture, if we can find the CDP message first. Here, this is the CDP. We will read the requirement of this for example the device. For example, let me to find the requirement of the 7960 IP phone 1. This is the 7960 IP phone 1 CDP message. Here in the CDP message we have many information. Let me to check the result in the packet tracer, and here we can see the CDPs, but the detail is not available here in the packet tracer. But in the real world, it can send that its requirement about the power or other important features. Because of that, after identifying the device, the other side needs power or not, okay, with the CDP and LLDP again simultaneous in interval times in by default 60 seconds. You know, in the CDP we are using 60 seconds as the interval, and in the LLDP is 30 seconds as the interval. We are negotiating about the need of power with the other side. If the other side needs power, we are applying the power. If the other side doesn't need the power, we shouldn't apply the power. It is so important, because if you apply the power to the, for example, one interface, one device that doesn't need power, maybe that device